Elements have puzzled scientists for centuries. Dmitry Mendeleev was the first to come up with a working periodic table that could classify all the elements. At the time, there were many missing elements. Mendeleev formed a table without them and predicted the missing elements. How is that possible? Today on Hows and Whys, I'll be explaining periodic trends. In this episode, we'll be going in depth into atomic radius. Mendeleev built his periodic table on the ideas of many scientists. Antoine Laurent de Lavoisier was the first to define and classify elements. He classified them as metals and nonmetals. Johann Wolfgang Dobereiner grouped elements based on their properties. John Newlands classified elements by their atomic number and noticed recurring properties. Dmitry Mendeleev created the earliest version of our periodic table. He ordered elements by their atomic mass and noticed that the order of their valences followed the pattern 1, 2, 3, 4, 3, 2, 1. This pattern seemed to appear for every 7 elements. Mendeleev placed the rest of the elements according to this pattern, leaving gaps for undiscovered elements. Mendeleev found that elements of the same group shared certain physical and chemical properties. For example, group 1 elements were all very reactive, whereas group 2 elements were slightly less reactive. Other trends also appeared. These are what we call periodic trends. Periodic trends include atomic radius, ionization energy, reactivity of metals, reactivity of nonmetals, electron affinity, and electronegativity. Today we will be focusing on atomic radius. Atomic radius refers to half the distance between the nuclei of 2 atoms of the same element. Atomic radius can be measured in 2 ways. Van der Waals radius can be found using 2 atoms of one element that are not bonded together. They are as close to each other as possible without bonding. Measuring the distance between the nuclei and dividing it by 2 will give us a radius. Similar to the van der Waals radius, we have 2 atoms of the same element. This time they are bound by a covalent bond. Measuring the distance between the nuclei and dividing it by 2 will give us the radius.